Good day, everyone. Welcome to another episode of Learning Science. Again, I am Sir Roy, your science teacher. And for this day, we're going to talk about percentage composition of compounds. So, let's begin. The most essential learning competency that will be covered in our discussion for today is to determine the percentage composition of compound given its chemical formula and vice versa. For our introduction, let us analyze the given situation. Suppose that you had your second periodical examination in science. When you get a score of 85% in the said test, what does it mean? It means that if there are 100 items in your test, 85% means you answered 85 items correctly. Let's have another example. You look at this figure. This is known to be the Baker's percentage, or in other references, you would see it as Baker's percent, flour weight, or Baker's mass. So this particular figure represents a way to express the ratio of ingredients to one another by weight. It is internationally used to express formulas for baked products such as bread, cookies, canes, scones, and most any product where flour is primary ingredient. So now, class, the advantage of this system is that it allows for the baker to easily convert their recipe into different weight indicators, such as pounds, ounces, kilograms, or grams. So as you can see in the figure, there are written percentages of the different ingredients used in baking. By looking at the percentages, it is easier to tell if one recipe is drier, sweeter, saltier, and etc. than another recipe. This can be used to quickly and easily convert between batch sizes as well. Now, what is the relationship of the given examples for our lesson today? So, I know that you are familiar with the word percentage. When you speak of percentage or percent, we are referring to something that indicates parts per hundred. In our mathematics, you would remember the formula percent is equal to part divided by whole times 100%. Or it is also represented by the figure written on the right side, which is, you will see there a circle, a part of a circle divided by the whole circle multiplied by 100. That is the procedure or methodology. How do we obtain the percentage of a particular number? Now, so it is somewhat related to our lesson for today, which is all about percentage composition. It means that the percent composition of a compound can be determined from the formula of the compound. It is necessary for us to identify first the chemical formula of the compound given. Of course, the subscript in the formula are first used to calculate the mass of each element in 1 mole of the compound. And that is divided by the molar mass of the compound and multiplied by 100%. That is how we obtain the percentage composition. Now let's have this formula. Percent by mass or percentage composition is equal to mass of the element in 1 mole divided by the molar mass of compound times 100%. So there are some things that you should remember. Take note that the mass of the element is expressed in gram per mole, and the molar mass as well is also expressed in gram per mole, so that we can cancel the unit. And of course, if we cancel the gram per mole, the remaining unit would be percentage, which is the unit of our percentage composition. Let's have this example. The given compound is ethanol. On the left side, you would see the structure formula, and on the right side, you would see there the molecular formula. By looking at the molecular formula, we can get or we can proceed to our step number 1. In step number 1, you have to determine the molar mass of the compound. Again, our first step is to identify the elements present in our molecular formula. Therefore, these are carbon or C, hydrogen or H, and we also have oxygen for O. Now, the next step is to identify the number of atoms for each element. For carbon, since we have subscript of 2, the number of atoms is 2. Then for hydrogen, since we have subscript of 5 and another hydrogen on the last part, we have a total hydrogen number of 6. And then for oxygen, since there is no subscript written in the molecular formula, it means 1. And our next step is to multiply it with the respective atomic mass which is found in the periodic table. In this example, I'm going to use whole number of their atomic mass. For carbon, we have 12 gram per mole. For hydrogen, we have 1 gram per mole. And for oxygen, we have 16 grams per mole. Now, our next step is to find the product of the number of atoms and their atomic mass. For carbon, we have 2 times 12 gram per mole. The answer is 24 gram per mole. For hydrogen, we have 6 times 1 gram per mole. The answer is 6 gram per mole. And for oxygen, we have 1 times 16 gram per mole. We have 16 gram per mole. The next step is to sum it up. So therefore, we have a total of 24 plus 6 plus 16, 46 gram per mole. That is our molar mass. So that's our step 1. For step number 2, we have applied the formula for percentage composition. Of course, our first step would be the prerequisite for this step. So this is the last step that we have uh, accomplished a while ago. Let us now apply the formula. Percent by mass is equal to mass of the element in 1 mole divided by the molar mass of the compound multiplied by 100%. Again, our first step is to identify the elements involved in the compound. We have carbon, hydrogen, and oxygen. Now we're going to use the product of the number of atoms of the element and the respective atomic mass that we have computed on our last part. So we have, for carbon, we're going to use 24 grams per mole. And you have to divide it by the molar mass. And our molar mass, depending on our previous step, is 46 gram per mole. So let us do the same thing with the other elements. For hydrogen, we have 6 gram per mole divided by, of course, the molar mass of 46 gram per mole. And for oxygen, we have 16 gram per mole and a molar mass of 46 gram per mole. In order to obtain an answer which is in percentage form, let us multiply all of them by 100%. So for carbon, we have 24 divided by 46 times 100. Let us express our answer into decimal digits. We have 52.17%. For hydrogen, we have 6 gram per mole divided by 46 gram per mole times 100. That is equal to 13.04%. And for oxygen, we have 16 gram per mole divided by 46 gram per mole times 100. That is equal to 34.78%. If we're going to sum it up, that is equal to 99.99% or almost 100%. So that is one of the clue if we obtain the proper or the correct percentage composition of a particular compound. So that ends our lesson for today. This is the reference that I made use for this particular presentation. Thank you for watching and do not forget to subscribe to my YouTube channel for more videos.